Now we can also talk about sharding this database into the multiple servers so that this consumer would be able to write into these database as it's a write heavy system. But let's take a step back and connect the dots from our requirement. These servers are, we are capturing the data every milliseconds from these servers pushing to the Kafka. So far so good, but do we really need to store all these millisecond information in our OLAP database to serve for the dashboard query? Probably every millisecond information might be required for analytics purpose for running the machine learning model, but we definitely do not need this granular level of information for our dashboard or alert system. So we can change this consumer to a aggregator service. What does this aggregator service can do is it can aggregate the millisecond of data into a second. So we can convert this from so that this database will have information at every second granularity level. For example, on 5th December 2024 at 9 a.m. on first second, the CPU utilization was 58 percentage. This is how this database can have the information at a granularity level of every second. Then the query service can query this database to load this information and populate in the dashboard. So far so good. But how about if we need the millisecond information for running our LLM models? We lost that information and it is not good. It is not the best practice to lose the information. We can get the millisecond level of information from the Kafka. So we can have the another service which can read these information from Kafka at a millisecond level and just dump it to any blob storage. We can introduce the blob storage which is cost optimized S3 as an example. So how does these data can go into our S3 bucket? So what kind of a service it could be? This service needs to continuously check in the Kafka if there are any messages and put into the blob storage. It could be simple lambda or it could also be a cron job here which can continuously check and push and just dump these raw data in our S3 bucket. Let me call this as raw data. Okay. So far, so good. This raw data can be used by the ML team for running the LLM model. And this is the real-time data that is being published in the dashboard. Here we also need to fine-tune our alert system. So this alert system cron job, let me just call this as a cron job. This cron job is periodically querying this query service based on the defined rules here. So this can query the query service. How does this rule would be defined? We would need the database for storing all those rules. So let's introduce a relational DB here, which is a rules database. This cron job is periodically querying this rule database to load the rules, and based on the rules it will query the query service, and if any threshold reached which are defined in this rules database, then this can send the notifications like email, SMS to the different stakeholders. How does this rules would be defined? So we need one alert and rule service here as well. So I'm calling this as, in fact, what we can do is, so we can define these rules from the dashboard as well. This dashboard can query to this query service to load the data. At the same time, we can also create or define the rules. So let me change this to alert db, and from this dashboard we can define the rules in this alert db. For example, if the cpu utilization is reached above 90%, then this cron job will periodically query this alert db and send the notification so that the stakeholders can take an action on it to scale up or scale down the servers in this infrastructure. And at this point of time, we have our scalable system for loading the dashboard, alerting, and working the end-to-end functionality. Still, let's try to figure out if there are any further areas of improvement, or rather you might get a question from the interviewer. Do you see if there are any further improvement areas in your design? So let's revisit each of these steps. These servers are emitting the events and are being published to Kafka, and we have aggregator service. Yeah, this aggregator service can be a Flink service from AWS, which is managed service that can aggregate the data from millisecond to a second to a level of second and store in this OLAP. But what happens if there are any messages which are missed, or the aggregation result, if the services are, some services are down for aggregation, or some messages are missed from this Kafka? So as a backup on this kind of a system where these aggregations are happening at the real time from this Kafka messages, we also need to think about the reconciliation process. So we can introduce the reconciliation service. Periodically get the data from S3 bucket and do a kind of a reconciliation on back to this OLAP database. So any information or aggregation result which has missed some messages as part of aggregation real-time process, this reconciliation service will make sure, and it will be the true source. Basically, it will override those aggregated results periodically. So we have all the data available in a form of a raw data. This service will fetch these data, do the aggregation, and save back to this OLAP DB. What kind of a reconciliation service is this? This is something like a map reducer. Let me mention here, map reducer, which can scale on its own to do this reconciliation. So we have the reconciliation process as well in our system. Let's check all the functionalities are satisfying, or have we missed any of the core functionality. Collect the database, store information, dashboard, rules, creating the rules, availability, aggregations, and this is a schema how we are aggregating in our, and yeah, coming back to this API. So now you see that you have started with one API, but for creating the rules you need more APIs. But I feel, considering the time what you have in your interview, it's okay to start with one or two APIs and then get into the high level system design and propose the end-to-end solution, how is it working, and then get deep dive and keep identifying the bottlenecks and the improvement areas into a system, and ultimately coming to the working solution for a scalable system. I hope you have learned something today. How we started with noting down the core functionalities and what are the quality of the system we need as part of the non-functional requirement, what are the data we need into our system and how we expose those data, and how we start scaling the system from a basic end-to-end high-level data flow to aggregating to decoupling these instances to decoupling this component by leveraging the message broker like a Kafka into our system, how we aggregated these data to not to save all this information so that it would be an overburden for a query service to query into this OLAP database, and how we are storing the raw data into the cheap storage, and we also introduce the reconciliation process, and at the end connecting with the end users on the dashboard, how it will query to load these information in the dashboard, and at the same time creating the alerts and running the cron job to send the notifications at the time of any threshold reached based on the defined rule into this alert DB. Please like and subscribe to my channel, which motivates me to create more such videos, and do check out my other system design interviews in the playlist. Enjoy learning. Thank you. Bye bye.